Hello everyone, this is Kene once again, okay? And today I am here with another Python problem. So we're going to solve a sorting problem using Python. And to do that, we'll make recourse to a way of thinking, an algorithm called the bubble sort algorithm. And so we're going to see what it entails, right? Okay, so guys, I'm going to share my screen and we will have a look at the question together. All right, so let's see. Sharing my screen. Okay, so guys, let's see. Write a Python program that accepts comma-separated numbers and outputs the numbers in ascending order of magnitude. What is this saying? So if I add 3, 4, just a moment, guys. I'll be right back. So I'm right back. So if I had 3, 4, 6, let me say 7, 2, 5, and 1, for example. So I'm going to rearrange them in ascending order of magnitude. What does this bubble sort algorithm entail? It's just comparing adjacent numbers. So say the number at position in the first position compared to the number in the second position. So if the first is greater than the second, we make them swap positions. So what was in the second position comes to the first position, and what was in the first position comes to the second position. And that trend continues to the very last number. Let's see, guys, together. So I have 7, 2, 5, 1. Then I'm going to ask, right, is 7 greater than 2? Asking just, is 7 greater than 2? So that's the thinking, guys. Is 7 greater than 2? Yes, it is. So 7 takes the place of 2 and 2 takes the place of 7. So they swap positions. That gives us this new series, 2, 7, 5, 1. So that's the new series of numbers. Right. So I've just compared the number in position in this first position with the number in the second position. Now the next time I'm going to compare number in second position with the number in third position. That is comparing 7 and 5. That's what it's going to be now. So is 7 greater than 5? Again, we see that 7 is greater, right? 7 is greater than 5. So 7 will take the place of 5 and 5 will take the place of 7, just like that, because 7 is greater than 5. So the new series will be 2, 7, sorry, that shouldn't be 2, 7 again. It's going to be 7, 2, 5, and 1, just like that, okay? So that's it. So now checking if 7 is greater than 5, right? We see that it is. We see that 7 is greater than 5, and that is why we have 7, 2. Oh no, sorry guys, I need to take this again. 7 is greater than 5. So 7 takes the place of 5 and 5 takes the place of 7. So the new series will be 2, 5, 7, and 1, just like that. All right, so I'm going to now compare this third number with the fourth one, that is comparing 7 and 1, right? So that will be, so I see asking, is 7 greater than 1? Yes, 7 is greater than 1. So 7 takes the place of 1 and 1 takes the place of 7, right? So the new series will be 2, 5, and this time 1 and 7. So that's how we run the process till we get to the very last number. So we see that the largest number must take the last position. So we must keep moving until the largest number occupies the last position. And then nothing is going to take it away from there. But we haven't sorted the rest of the numbers, right? So I'm going to repeat, we would have to repeat this process so that the largest now, besides 7, so we're taking 7 out. The largest, apart from 7 this time, will now occupy the position just before the last, because already we have 7 as the largest. So the next, in terms of magnitude, will occupy the position just before the last. So repeating this same process, we'll get the new series as 2, 1, 5, 7, right? Then I'll repeat the process. And this time we are going to compare just 2 and 1, right? So we would have 1, eventually, guys, 1, 2, 5, 7. But what actually happens is that the computer checks for every number. There is, the process runs for every number, but I've just tried to reduce it so that, I don't have to write it, because ordinarily we should have this repeated 4 times. We should have it running 4 times, okay? So I hope we get it, guys. Right, so now let's get the code for it. So to do that, I'm going to take the input from the user, so values separated by commas. But you would agree that eventually we'll need to split the numbers so that the numbers are separate entities. We'll be needing the numbers as separate entities. So 5 should be a separate entity from 8, and 8 should be a separate entity from 1, and on and on. And I'm going to split the numbers by commas, since commas are the separator. So it's just good to split them by commas. So I have just numbers left, okay? But a user may erroneously include a letter. So there has to be a way of removing the letter, just sieving it out. So that's why we are using, so I'm going to import this regular expression module here, all right? And I'll use a sub method, the sub method called sub, and then give it a pattern. So what we're saying is, A to Z, if it finds any letter from A to Z, it should replace it with something. Either it's a small letter or a capital letter. Just replace it with nothing. Therefore, let the letter disappear. It should just vanish. That's why we have this empty string. Then what input are we to work on? That which was collected from the user and stored in this imp variable, right? Okay, so I'm going to do something now, guys. I don't want, so this goes off. And again, let's say the user created a comma and a space. So that's also going to be a problem, because the computer will create an entity. When we split by commas, it will create an entity as though it were a number. And we can see that it's not a number there, it's just space. And a space is treated as a character, okay? So there has to be a way of removing this space after the comma. That's what we're going to do here. So I call the replace method of the string class. So this imp, what do I need to replace? I'll call the replace method. I need to replace space with, a comma with a space. Then I replace it with just a comma. So the space is taken off. Then I'm going to, see guys, when we remove the letter, you see that there's a problem here. We got 2 commas with nothing in between. That again is a problem. So how do I take off the 2 commas and replace with a single comma? Again, I'm going to chain a second replace method. This time, I'm replacing 2 commas with just a single comma. So that's what the replace method does in Python. Great. Then I'm storing what is returned in this variable called int without space. And then lastly, at this time, I'm just going to split the input imp without space and call the split method. It's another string, a method of the string class. And I'm going to split it by commas so that I have different entities in the container. So that's what I have stored here in this list variable called num list. So a proper Python list is created using this split method, right? Okay. So guys, we've got our input in the form that we need it. The next thing now is to begin, initiate a loop and do the test to see if we should swap, if two adjacent values should swap positions or not. So I'm going to use the for loop. For I in range, so going from 0, I don't need to put the 0. If it's going to start from the beginning, then the default is 0, but I'm just going to put it there, okay? In range 0. Now, what's the length of that list? I will use the len method to get how many numbers there are in the list of numbers. Len and give it the name of the list. Now, the len method, something about the len method is that it gives you the actual count. So if there are 5 members or 5 elements in a list, it will return 5. But if you're using a for loop and you need to do something repeatedly, it's going to start counting from 0. Computers count from 0, right? And say I have 5. So when it gets to the 4th count, it would have gone through all the numbers. That's a problem. So if I have 5 elements and I'm using the len method, I need to take 1 off so that it runs from 0 to 4 to have covered 5 numbers. We need to understand that concept. So I'm going to say len numList minus 1. So that will give us everything, all the members of that list. Please remember the minus 1. And then we're going to check. So the value at this index I, which at the beginning is 0. So value at index 0 is the first number. That's the first value. So if numList, right, at index I is greater than the number just after it. So, we're looking at adjacent numbers, A and B, for example. So the very next number will be that which lies in position I plus 1. If I is the current position, then the next position will simply be I plus 1. So numList I plus 1. So that's it. So if numList I is greater than numList I plus 1, then we should make them swap positions, right? So simply put, well, guys, the thing is, I need a variable, something to keep the current position of the number at index I, because I'm going to now assign numList 1 a value of I'm going to assign numList I plus 1 a value of numList I. So I'm going to create a variable to hold numList I, that first number, before I assign it to the position of the number after it, so that the number after it will now come to the position in front. So that temp var will be numList I. Then, having done that now, I can now make numList I, any number at position I, become the number at position numList I plus 1. So the swapping has taken place here. Then I mustn't forget now to assign to numList I plus 1. I will assign it the value of numList I, so that A has become B and B has become A, right? So numList I plus 1 becomes the value of the original numList I that we stored in that temporary variable, that temp variable. So I'm going to say numList I plus 1 is equal to temp, that variable we created. So that's what we have done. We've done the swapping successfully. And then at the end of the day, we just need to print the list of numbers. So if I print the list of numbers, whatever I give, you would see that for this first iteration here, it is the largest number, only one, that is the largest number that is placed in the last position. The other numbers remain where they are. Only the last one is placed in the last position. So let's see if that's actually the case. So I'll print. To output something to the console, we know that we use the print method, right? So print num list. Let's see. So I'm going to say 5, 9, 1, and 4. So that's right. You see that 9 occupies this last position. That's correct, right? Good. So we now know that since this works, all I need to do now is to repeat the process by how many numbers we have. So if we have, say, 4 numbers in the list, it will be done 4 times so that the numbers are placed according to their, the size or the magnitude. That's what it's going to be. So to do that, now I'm going to create an outer for loop to repeat the same process. Okay, guys. So just take for I, or this time let me say j, because I can't have I in 2 places. For j in range 0, then num list -1. Okay, so repeat the same process. I'm going to indent all this. So that shows the hierarchy. This inner for loop is kind of a child of the outer for loop, and that should be indented. I'm just going to indent it. That's the way Python works. So that's it. Now let's run the program again. I'm going to print. So having repeated the process by the number of numbers we have, I'm going to print the result. So print that list of numbers. Okay, so let's see, guys. So I will take 7, 9, 5, 2, and 1. Voila. Isn't that easy? So I have 1, 2, 5, 7, and 9. So what we've done now is arrange numbers in ascending order of magnitude using the bubble sort algorithm. Now, guys, I need to say something here. For real projects, you don't want to use the bubble sort algorithm. This is just for educational purposes. Okay, why? Guys, you see that it is just too repetitive. You have to go through all the numbers, and they're not just going through all the numbers. You need to compare adjacent numbers. So if I have 1 million numbers, for example, I need to compare the numbers at position 1 and position 2, numbers at position 2 and position 3, till I get to the 1 millionth number. Then I'm going to repeat the process 1 million times. I mean, for very large projects, you don't want to use this algorithm. So I just need to, say that. But I just hope you understand what sorting is like. If I have the time, we'll look at another sorting algorithm called the bucket sort algorithm and how we can sort numbers. All right. So thank you guys for your time. I'll see you in my next video. Bye.